This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
Welcome, everyone. I'm Kim Shulman, and I have the distinct pleasure of introducing Meg Urey, the keynote speaker for this roundtable. Meg is the Israel Munson Professor of Physics and Astronomy at Yale University. Her research focuses on actively accreting supermassive black holes, the coevolution of these black holes with normal galaxies, and she is simply one of the most influential astronomers of her generation. To name just a few of her achievements and leadership roles, she is a fellow of both the American Academy of Arts and Sciences and the American Association for the Advancement of Science. She is the founding and long-serving director of the Yale Center for Astronomy and Astrophysics. She just completed a term as the chair of the Department of Physics at Yale. She is the incoming president of the American Astronomical Society. She has served as director of the Yale Women's Faculty Forum, and she has chaired or participated in very many department site visit teams for the American Physics Society Site Visit Committee and for the Committee on the Status of Women in Physics. Excuse me. She is an outspoken and seemingly inexhaustible advocate, and she actively works to increase the diversity among scientists, focusing most specifically on academic science, both the pipeline and amongst faculty. Her activities on that front are really, really too numerous to list. And although she sometimes describes herself as jaded on this topic, the topic of increasing diversity in STEM fields, her actions speak much louder than her words. She has tirelessly advocated, and she is an activist like none other on this issue. And this activity belies the core optimism that she has, and her belief that transforming science to embrace the full diversity of participants and perspectives is not only essential if we are to realize the full potential of science, but it is also achievable. Please join me in welcoming Meg Urey.
Well, I'm really honored to be here speaking to all of you, and I congratulate you on the work you're doing with ADVANCE. I have to say, as a physicist, astronomer, the single biggest change I've seen in my career has been stimulated by the ADVANCE program. So big shout out to Alice Hogan, who invented it, and we're all benefiting. I want to start with a story also. Some years ago, at a major U.S. university, a visiting faculty candidate, a woman, was told by a senior colleague, a man who was a Nobel Prize winner and the director of a very influential institute at that university, that she would not be welcome to work with him, that he would not be funding her, giving her other resources, and that his research group would be reluctant to talk to her about science because they were basically in competition with her. She wisely decided to build her career elsewhere, but not before she described these events to others. She leaked one of his emails, and the university, to others at the university, and eventually got to the press. That's why I know about it. And the ensuing scandal created a sort of classic dilemma between bad or undesirable behavior and outstanding science. You know, I don't have to tell any of you how important Nobel Prize winners are to universities. Many of us feel we have too few of them, and we certainly don't want to get rid of them. And I can guess what the president of that university was thinking about this event. You know, the guy might be an idiot, but he's a Nobel Prize winner. I mean, And he's done this amazing science. He's incredibly valuable to us. So I don't know many university presidents who would be willing to penalize a high flyer like that. Although he was investigated, there was a committee and so on. If you did nothing but subtract him from the picture at that university, then clearly the university would be the poorer. The scholarship would be the poorer. But let me propose an alternative reaction to what happened, a different view. What if you had a senior faculty member in charge of a major institute at your university who was not only a Nobel Prize-winning scholar, but was also supportive of young scholars and interactive and encouraged interactions among scholars, who saw their role as nurturing and supporting them as opposed to competing with them, and who thought not only about what his lab what she might learn from his lab, but what he could learn from her. I would argue that the achievements of that institute and that university would be greater. So it's not an issue of how much bad behavior are we willing to put up with to have the high flyer. It's let's hire high flyers who are also superb leaders. Conduct, climate, as I hope this anecdote begins to say, has a really strong influence on the science that gets done, on the generation of knowledge, hence the title of my talk today. Don't get me wrong, I am not suggesting that competition is bad or that the level of scholarship is not the preeminent quality with which we should be concerned. In fact, I think scholarship is the business of the university. Creation of new knowledge is the business of the university. So it's our job to make sure that it happens as best as it could possibly happen. What I am suggesting is that the atmosphere in many science departments, and probably today I'll pick mostly on physics departments, is not great. Aggression and assertiveness are often seen as proxies for talent. And I would argue that aggressiveness and assertiveness does not lead to the best science. Now, many of us have worked in unpleasant places. I mean, anyone want to volunteer? Not now. What happens? You spend a lot of your time thinking about the bad things that happen to you. You're out in the hallway complaining to your colleagues, and they're complaining to you, and you're trying to calm them down so they don't leave you alone to suffer. So it wastes a lot of time. A lot of energy gets dissipated in ways that are not useful, or at least not useful for research. So it's channeling energy away from the research effort. In the worst case, the scientific productivity of people who are somehow misfits, meaning minority members of a department in some axis, can be badly affected by toxic environments. And they can confirm preconceptions that these kind of people aren't very good at science. So we can't afford this. As all of you know, as well as I, humanity cannot afford to this waste of brains. We have a lot of challenges facing us, many of them rooted in STEM issues. Just to give a small list: climate change, economic growth. Estimates from reports in the last decade have suggested that as much as 75% of our current economic growth is due to basic research in the physical sciences 80 years ago. That's your iPod we're talking about. Energy, water, pollution, education, cybersecurity, yada, yada. There's lots of technical issues facing the country, and we need a workforce who can respond to those challenges. Now, as this morning's speakers have already alluded, one of the problems with making change in a university is that many faculty in the university think the research enterprise is as good as it could possibly be. After all, we're first in the world, maybe. We have a lot of Nobel Prize winners, not all of them any longer, but many, et cetera. So they think that any change is bad and is basically a step to the side, if not a step backwards. Now, you guys know, and Linda has explicitly said, increasing diversity is equated with excellence, but many think it's equivalent to lowering standards. So I know, I'm preaching to the choir, and I know you've discussed this in previous roundtables. My point today is slightly different. It's not just that increasing diversity increases excellence. It's that the climate in which these people, in which diverse and majority people work together, can affect the research output strongly. And excellence is diminished when scientists are not able to be at their best. Okay, think about the best research you've ever done. How many of you are research scientists? So sort of half the people in the room. Okay. Chances are your best research was done in a collegial environment where you could speak openly with your colleagues. You didn't worry so much about who was going to win the race or who was going to get credit. You were just bouncing ideas back and forth. And it's even more useful to bounce ideas back and forth with people who think differently than you. You know, you can go in a room and write a paper by yourself, but you're not going to think of all the things that are wrong with your ideas. I can promise you. You look in the mirror and you think, those are excellent ideas. So the myth of the lone genius working in the customs office, as Einstein did, has probably done more to impede science than to move it forward. When I worked at the Space Telescope Science Institute in Baltimore, before I moved to Yale, I saw teams of people working together to build the Hubble Space Telescope, a $6 billion project. They worked together to calibrate it, to interpret the data, to support the users of the telescope. Almost never did a lone genius come up with anything working entirely on his or her own, although plenty of individuals were rewarded for their lone contributions. After one meeting of a tenure committee, I remember this senior colleague of mine muttering under his breath, "That's a third person we've tenured for, you know, having done that thing solo." That was the culture. You know, being a team player was essential to getting things done, but it was not a compliment. If you were called a team player, that was basically a negative. Somebody in a letter of tenure letter said you were a team player. That was the kiss of death, right? So. And we see the same importance of teamwork in other projects, you know, the $10 billion Large Hadron Collider. I have colleagues who are in the 2,000-member ATLAS collaboration, and they work in a highly collaborative, highly collegial manner. I mean, they're tough competitors, don't get me wrong, but they know they have to work together to pull out from that machine everything it's trying to tell us about nature. And although you can only list 3 or fewer names on a Nobel Prize award, it's often teams that are making the progress or enabling the progress. Okay, so while increasing diversity is surely about excellence, and improving our hiring and promotion processes is essential, it's not sufficient. To get the most out of our scholars, we need to enable them to be as brilliant and as creative as they can, as they truly are. We have to provide a good workplace. The faculty candidate from my opening anecdote today was quoted as saying, after she took another job, that she looked forward to the unprecedented opportunity to just focus on science and to have a lot of fun being in a highly collaborative environment. So she voted with her feet. Last year, some speakers at the roundtable talked about how diversity stimulates innovation, and I'm happy to say that that concept is being discussed not just at advanced institutions, it's actually becoming a broader understanding. But the research shows that diversity also leads to more conflict than do deliberations among homogeneous groups. And if that conflict is well managed, then you get the innovation and the creativity. But if it's left to fester, then diverse groups do worse than homogeneous groups. So one of the worst things we can do is hire women and minorities into STEM departments and then just let them sink or swim in the toxic environment. That doesn't help the young faculty members, nor does it help the STEM enterprise. Okay, so let's talk about collegiality and climate. What is the climate like in academic science departments? Clearly, it varies a great deal from one place to the next. That's what tells you it's local culture. But there are some common themes. I come from a tradition, so in physics we do site visits, which we'll talk about this afternoon, but let me just say a few things now about them. And I should also say that physics is one of the, I call it the desert. It's where there are the fewest women, I think, except for electrical engineering, Linda. I think we're in a tie for bottom place. And And, so what I'm telling you is sort of the extremum of how things can be, but I think that's a useful experimental model to look at when you're trying to improve the situation. So at site visits, well, let me start with, I have my own literary quotation. It's not Shakespeare, because I didn't know it was his 450th birthday, but Tolstoy from Anna Karenina said, "All happy families are alike, and each unhappy family is unhappy in its own way." I think site visit teams might say the opposite, which is that unhappy departments have a lot in common. We talk to the students and the postdocs and the staff and the faculty and so on, and we see that the undergraduates are usually pretty happy. They're very eager, they're highly motivated, they love physics, they're running their student societies, et cetera, physics societies, and enjoying themselves. The first and second year graduate students are very similar, of course. They're only a few years beyond. They're a little more stressed because they have to take qualifying exams and pick an advisor and so on, but they're in good shape. And when you get to the senior graduate students and the postdocs, you see some enormous change, particularly among the women. Many women are discouraged, they're unhappy, and they think they've made a mistake in doing physics. They think not that physics failed them, but that they don't have a talent for it. So 4 or 5 years in graduate school has taught them what Eileen Pollack, the author of the New York Times article in last October, managed to learn as an undergraduate, right? She got the message that she wasn't any good at physics, even though, if you've read the article, she was absolutely brilliant. One young woman we talked to, who was actually known to one of the committee members, one of the members of the site visit committee, because they were in the same field, she was known to be a really outstanding graduate student who had a very promising future. And I remember vividly what she said to us. She said she made a terrible mistake going into physics, that she had no good ideas, that she couldn't write a grant proposal if her life depended on it, and that she was just hoping to finish her degree and get the hell out. This kind of attitude we found much more prevalent among the women than among the men. The women faculty are actually in some ways the saddest part of the story. In many places, they're on the sidelines, they're marginalized, and they're seen, or at least treated, as if they're less productive and less able than the men. Even those women faculty who are held in high regard by their colleagues are often the hardest working people in the department, and that's not really recognized, because they're doing things that the department doesn't recognize as valuable, like creating courses for people who aren't majoring in physics, or doing outreach to younger people, and so on. Doing outreach to the humanities. There's a species on the other side of campus. They have a different language, but they're very interesting. One time, as the chair of a site visit committee, I was debriefing the department chair, the physics department. This was a highly ranked department in a highly ranked university. And I happened to mention, this was a place where the women were really, they had checked out some time ago. And I mentioned that one of these women had been an absolute superstar, a rising young superstar when I was a graduate student. And that I remembered when his university had hired her away from the top place she had been before. And that, I just was so puzzled by why she now seemed to be less productive and was not highly regarded by her colleagues. In fact, they treated her, I thought, like the furniture when they weren't belittling her or yelling at her. And he was really startled. I think that was the first time that he thought not about the social value of, hiring diverse faculty, but about the actual science cost of not having a good climate. It's interesting to compare the climates in physics departments and astronomy departments. I have sort of a foot in each because my research is in astrophysics and in black holes, and my training is all in physics. I never took an astronomy course. I try to hide it, but since we're being filmed, it's out, okay? Too bad. Anyway, astronomy and physics have the same skill set, exactly. Same math skills, same computing skills, same physics skills. But they're very different socially, culturally. Historically, the fraction of astronomers who are women has been about double the fraction of physicists. They've tracked really well over the last 25 years. And you see in astronomy that people seem a little more collegial, a little less ego-driven, a little less, over-the-top elitist. you're more likely in a physics department to have a colleague come tell you how great they are. In an astronomy department, they'll just send you an email saying, did you see my press release? It's a little less, you know. Okay, that was a joke, really, I didn't mean that. Okay. So in departments with troublesome climates, a good fraction of the faculty think the same way. I call this the 25 brain. You know, they're kind of like one humongous brain in some science fiction movie that's, you know, fueling 25 people. I don't know whether they actually think the same or they've just conspired in the back rooms before the faculty meeting to have the same view, but in any case, they have difficulty appreciating other views. And to the extent that those minority views belong to women or minorities, they can really exacerbate the tensions in a diverse, especially a newly diverse faculty. Of course, let me say, the majority do not see themselves as I have described them, as the 25 brain. They see themselves as individuals who are fair and objective and unbiased. Many years ago, I was complaining to Sheila Tobias, who has written a lot on women in science and other related issues. We were in a bar somewhere at a meeting, and I was complaining just how hard it was for women who had all these extra obstacles and so on. And she said, oh, I wouldn't trade places with them for a minute, meaning with the majority men. She said that because they don't get cues that they're wrong the way the minority do all the time, it never occurs to them to examine their interactions with others or their value systems or whatever. So they have much less self-knowledge than people who are misfits. And so I really learned a lot from that comment, and I've tried to think about it since then. So I think I've just insulted at least a third of the audience. Is that right? Something like that. But I'm serious to a point here, which is that, you know, if you're in the historical majority, and I certainly am in a white majority, historical majority, although we're soon to be the minority in the US, but when you're in the majority, it doesn't occur to you to think about the privileges you have. And it's also much more comfortable to talk to people who agree with you. You know, you can cite Fox News or MSNBC as a sign of that. I have another story that really taught me a lot about it. It was about 20-some years ago. We were organizing the first meeting ever on women in astronomy. Bunch of young people who didn't know what they were doing. We held that meeting in Baltimore in 1992, and we wrote this document called the Baltimore Charter. You know, go look at it. It's interesting. We thought, well, we didn't think. We thought it was great. The community thought it was so radical. You know, very few institutions actually tried to ratify it. But if you look at it now, it just looks really old-fashioned and kind of toothless. Anyway, we were organizing this conference, and you know, it was obvious to me and my friend Ann Kinney, now working for NASA, it was obvious to us that this had to be about the obstacles that women face in pursuing a career in astronomy. But at the very first meeting of the organizing committee, one of my senior white male colleagues said, no, this meeting is about, are there extra obstacles for women? And, you know, I argued with him for a while, and then luckily, later I thought, oh, you know, number one, if that's the question he's asking, we need to answer it, for sure. But also, you know, little introspection, why didn't I expect that comment? And it's because I only ever talked about diversity with my women colleagues. We talked about how bad it was, and we all agreed on everything. And so we didn't have a very diverse view of diversity, if you like. So that guy actually, difficult as he was, you know, was very helpful in a way. I do think it was strange, to me it's still strange, that he didn't see anything odd at being at an institution that had hired science faculty almost, you know, from the mid-'80s on, and had one woman on the tenure track staff out of 60 people, at a time when women were, you know, roughly 10% or more of the astronomy PhDs. He didn't see that as odd. Okay, and I think that most majority white male scientists who dominate our science departments at your institutions and at mine, they don't see anything off kilter about these unbalanced arrangements. Many of them, including at Yale, think it's a good thing to have a diverse faculty, and they welcomed me when I came there. They were glad to have the first tenured woman tenured woman in the physics department ever, 2001. One of my colleagues who was not there when I arrived, Karen Robb, was tenured a few years earlier than I in the applied physics department. So those were the first two women ever tenured in physics in Yale. It's 300 years old. But they didn't see anything particularly strange about that. And I think it's the same everywhere in the academy. And I think in science particularly, it's hard to talk about things like implicit bias, which I'm sure this audience is very knowledgeable about, because being objective is so central to our identity as scientists. You know, we can say, well, those psychology students who were your lab rats, they're one thing, but we're scientists, we're objective, we don't do that. And of course, the famous Moss-Rakusin paper from whenever that was, a year and a half ago, has maybe taught some of us otherwise. Oh, I meant to say that we all really, really want to be gender blind and colorblind. Many of us realize you can't say that anymore because it's not true, especially if you visit implicit.harvard.edu. But a lot of my colleagues are really offended at the thought that they're anything but. Okay, let me tell you another story. This is a long one, but it's important. Because it illustrates this lack of self-scrutiny and the inability to see one's own behavior in a pattern, let's say. So in 2007, there was an annual meeting of physics department chairs run by the American Physical Society at their headquarters in College Park, Maryland. And in 2007, that meeting was devoted to the issue of gender equity. I was on the organizing committee. Was anyone here there? Anybody? Adam was there, and Jeff, of course, was there. Okay, just a few of you. So, we had great ambitions. We were going to sort of teach department chairs about implicit bias, and then they were going to go home and fix their departments. And one of the most important parts of the meeting is we arranged for the University of Michigan CRLT players, of which Jeffrey was then the head or director or something. This is a group that was created originally, I believe, to create skits around academic life to teach teachers how to teach better and things like mentor better and so on. But when the advanced program started at Michigan, they took on the job of also creating skits that related to gender in STEM departments. And if you're not familiar with them, they developed their scripts, their skits, from extensive interviews with people about events that really happened to them. And in many cases, they're using the exact words that were told them by people to whom things had happened. So we saw the faculty meeting skit, which I've now seen 3 times. The first time, it was so chilling because it was exactly my life right there. I was shaking. So at the chairs meeting, there were not many women chairs. There were maybe 1 or 2, but there were about a dozen women at the meeting because we'd organized it, many of us. So we all sat in the front row, and I remember we were laughing a lot because all this stuff was so familiar. It had happened to every one of us, and it was awful. So what do? You have to laugh. But I thought it was wonderful, right? And afterwards, I rushed up to friends who were chairs who I knew, and I said, "What did you think?" Thinking they'd all think, "Oh, my eyes have been opened." I don't know what I thought. I was kind of naive. And one of them said to me, "Well, it just wasn't realistic." No one would behave that badly. It's just... Now, if you haven't seen the skit, I have to describe it because it's important to my story, okay? There are 6 faculty members. They're discussing some minor business, and then they discuss a faculty hire, whether to hire this woman or this man. And that's the meat of the skit, but I want to focus on the first part, which, as I recall, was about how some Xerox machine was going to be charged or something. So the chair begins by saying, okay, we have this issue with the Xerox machine, and here's what I propose we do. And another guy says, who's his henchman, says, yeah, that seems like the right thing. And then the tenured woman says, well, I think there's a better way, and she gives detailed reasons. And then a junior guy supports her statement. And then a couple other guys come in and say, no, what the chair said was right, and so on. And then the discussion kind of goes on, and then the chair says, well, we're all agreed, we'll do what I said. Now, I told you this is a long story. So at the reception, everyone said it was unrealistic behavior. The next day, we had breakout sessions where small groups would go off and discuss some scenario they'd been provided. And a friend of mine, a woman, told me what happened in one of her groups, so in the group she went to. So the scenario they were discussing was a case where a bunch of faculty are on a group grant. So this is pretty normal in nuclear and particle physics. There's one PI, but really each task on the group grant is sort of has its own individual faculty leader. And the granting agency is giving them the amount of money they think that person should have to do their research. So in this particular scenario, the PI, the head of the whole thing, wanted to take the money some woman had been, for her research been given and use it for something else. And she had complained, she didn't want this to happen, and she complained to the department chair, and the question for this set of department chairs was, what should you do about it, okay? So the meeting opened with the convener of the group, who was a senior white male, saying, well, let's just start by agreeing this has nothing to do with gender. And several other guys said, oh, the women are laughing at this. That's so interesting. Several other guys said, yeah, this has nothing to do with gender. It's just bad behavior. And then my friend, the senior woman, said, well, I disagree. I think it has everything to do with how gender intersects with power. And she went on to give a bunch of reasons why this was the case. And a junior woman, the only other woman in the room, said, yes, I agree that I think it is related to gender. And then several men basically said, well, it's not, and here's why. And then the discussion moved on, and they went on to talk about how you should deal with this as a department chair. Okay, I'm getting to it. When the full conference reconvened after the breakout session, each convener reported what their group had done. And this man got up and started his presentation by saying, first, we all agreed that this scenario had nothing to do with gender. Exactly the Xerox machine. Exactly, right? And unfortunately, I only found this out the next day. Otherwise, we would have had a teachable moment. The scenario simply described bad behavior. No one would ever do such a thing. So the point is, we don't see ourselves, none of us, not me either, we don't see ourselves as others see us. And changing culture kind of requires that we observe the current culture is not optimal, right? So the 25 brain think the current culture is just fine, and science is as good as it's going to be, the way things are now. Okay, so let me close my talk with two very positive points. I kind of said a lot of down stuff here, so let me say the good stuff. First, as I said, I've been in astronomy and I've been in physics. And so physics today is still pretty, I would say, behind the curve. But it looks exactly like astronomy looked to me 25 years ago. It has the same numbers, percentages that are women. It has the same attitudes, that kind of, well, diversity would be nice, but nothing we do has to change. That kind of attitude was there in astronomy in 1990. And now astronomy has reached a tipping point. We have enormous numbers of women in our undergraduate and graduate classes. In the last 5 years, half the PhDs have gone to women. Women are getting the appropriate percentage of faculty jobs if you relate it to the PhD fraction 6-7 years earlier, or 10 years earlier now that you have to do many postdocs. Women are starting to get some of the big prizes that are not designated for women. Those are the ones we used to get, only the ones we used to get. So I think if astronomy could change, I think physics can change, and that means anybody can change. My second closing point, optimistic point, or whatever, is that there's some outstanding women, senior women faculty out there who are very disaffected from their current departments. And if places like the universities of California can get ahead of the curve, you can make some outstanding acquisitions. So there's power in being ahead of the curve. Thank you. Yeah, I think we have a break now, but do you want any Q&A before we? Yeah, I think 15 minutes of Q&A. Okay, please.
Yolanda Moses from UC Riverside. I want to ask a question about white male culture in the sciences, and to what extent has the influx of international male and female faculty had on these shifts and changes? Can you speak to that, or is that an issue at all? Because
sorry, it's a really good question. I'm not the expert. Probably there may be people in this room. I will quickly say it's an interesting question because it's very different from one department to the next.
Right.
I think now, in certain places like computer science, it's the influx of international computer scientists that changed the gender fraction in the mid-'80s, the gender fraction of women. And of course, the people coming from international settings have different attitudes.
Right.
I'll give you one funny example, which is a colleague at a Caltech, who's an astronomer. I asked her once, why doesn't this stuff bother you? She said, oh, I grew up Catholic in Scotland. So, it does have an impact. Is there someone here who's more of an expert on the international? Linda, please, of course.
Yes.
So two things. For women, it is true. When I came from Greece to the US, I thought it was like the paradise compared to what I had before. But at the same time, it takes a period of 5 years to really live into the local environments and feel the same things like everybody else. So it is a transition, but it's very quick. So if the faculty, usually we recruit mostly faculty who are international but have really had an extensive education in the US. And so those individual women have gone through that experience, through that transition, I would say. So it's not a problem later. With international men, is a little different. We have not done an extensive study, and that's a type of research in some ways that needs to be done. But I think the challenge we have is that we bring cultures that are impacted by different traditions, different religions, and while the individuals are very educated, most of the time, all right, if not all, very progressive, that's why they've been here, yet at the same time, they bring those experiences that somehow make the dynamic more complex. Mm-hmm. The one thing that I faced as a woman faculty, as a female faculty, was not so much with my international colleagues as with my international male students, who would really question my leadership within our research group. And at some point, that became a serious problem for me. Because they tried to be defiant, all right? And it was very interesting dynamic that you don't get here in the US. So I think this is only one personal experience. It's very hard to generalize out of personal experiences, but I would say it's an area that needs to be looked at a little more carefully.
Yeah, thanks. Thank you. That's I resonate with some of your experiences, actually. It reminded me of something else. We had a meeting in 2002 of international meeting on women in physics, and it was really, we asked everybody to come in with statistics about what the fraction of practicing physicists in their country were women, and it was fascinating. It was not the numbers you would have guessed, say. In countries with really superb maternity benefits, for example, parental leaves, like Scandinavian countries, I think in Sweden the fraction of physicists who were women was 3%. In countries where you might have thought women were somehow subordinate, like, for example, Iran, which has a religious culture that is somewhat gendered. In Iran, 50% of the physics majors are women as undergraduates. In India, it's 50% up through the master's degree, and the Indian woman who, and then it drops sharply to the PhD, and the Indian leader of an institute explained this to us, that up through the master's degree, you're making yourself more marriageable. And then if you get a PhD, you're less marriageable. I get that. I do get that. Anyway, but the differences from one country to another really tell you about the cultural influences are huge. Other questions? Yes, here and then behind you after. Yeah. If you want to shout, I could repeat the question.
Sure. I'm Elena Fuentes-Affleck from UCSF.
Let me say that. Elena Fuentes-Affleck from UCSF.
Yes.
Thank you.
Will we be speaking about how to change that 25 brain? Because what I struggle with is how much can be from the ground up and how much really has to be at a leadership level. we're fortunate in San Francisco, our chancellor was a woman. We've had our first woman chancellor who's now left. Here at Davis, you have Chancellor Kategi. But how much of this can be accomplished at the different levels? And will we be speaking about strategies to talk to leaders in an effective way to also change our culture?
What a good question. So I'll just summarize it very briefly as saying that, will we be discussing how to change these cultures, how to change this 25 brain? So let me give a very brief, my view on this. The only effective change I've ever seen in any circumstance has been from the top down, a leader, someone with authority to make change, and frequently it's a man. The number one requirement is that you be committed, and I think the men and women are equally committed, but I think women have a harder time making the case because we're suspected of self-interest in a way that men are not. So white men can do the very most for change, I think, of anyone in the game. They have credibility because they don't have self-interest. We don't either, but they don't get that, okay? And then they also, it's playing against type, and they also lead our universities. If you look around, most of the presidents of universities are majority men. So I think they have the power, and if they use the power, they can make the change. I'm not saying that's the only way, but that's the way I've seen it happen. Well, should we do, yes, you had a question.
Okay, I'm Harry Green from Riverside, and I don't have a question, I just have a number of things to say relevant to what you were just saying. I'm an old white man, so I'm part of the problem.
And part of the solution.
And I believe I'm part of the solution, but I could have been part of the problem. But 20 years ago, I had a young wife who was a beginning assistant professor. She's also international, but I don't think that's relevant to the discussion, but it might be. And I began to hear the damnedest things I'd ever heard of that were happening to her. And if I hadn't lived it, I probably wouldn't have believed it. So I think that's a really critical part of this whole problem. If you've lived it, you can live it vicariously, as I have, you come to understand how deep it is and the most absurd things that happen, which I'm not going to recount here. So that's one thing. And the other is, when you get to a high enough level that you think you can do something about it, you have to have the power. I am currently the chair of the University Committee on Academic Personnel, and what I'm about to say, I would prefer didn't leave this room.
Well, it's being filmed.
It's being filmed, so I'll live with that. But I would still prefer it, but I will live with it. I tried, Susan can testify to this, I tried this year to interest the University Committee on Academic Personnel with a member from each campus to try to figure out how CAPS could take a proactive stance in trying to address some of these issues about merits and promotions in particular. And at my last meeting, my committee turned me down. They decided they weren't interested to do that. So yes, I think you have to live it in some sense, and you have to have the power if you're going to change something.
Yeah, there's relatively little incentive for power structures to change. Your comment reminded me of two things. One is, I don't know how many of you know the story of Barris, who used to be a woman and changed to a man. And he wrote a wonderful piece in Nature about the experience of being a woman in science, followed by the experience of being a man in science, which was one of the rare cases where you really could do an experiment. And it's a good article, I recommend it, but the quote that's best remembered perhaps is the person he overheard saying, "He's a much better scientist than his sister." So anyways, to come back to your point seriously, where I see action happening in departments and in personnel committees, the people who are the majority do not want to change. They don't think there's anything wrong with what's happening now. They think it's leading to the best science. And I think until they're persuaded otherwise, they certainly won't initiate the change. Perhaps leaders can make it happen. Thank you.